Now we have completed the main section, that is numerical problem regarding the topic which we have learned. Now we'll deal with another portion, and it's a theory, guys. Please listen to it. And from this topic we'll have a collaboration of both numerical section and theory. Now while listening to the earlier numerical problem, you might have felt some problem, that is, it might be felt as speedy, right? So what should you do? Pause the video for each question, listen to it properly and try to do it by yourself, right? So each topic I have taken it in a simpler way, guys. It was not a complicated stuff, just understand the logic, then it is very easy to understand the numerical section. From the first chapter itself I am giving importance to the numerical, because from 11th it is a bridge for 12th, right? So from 11th itself you have to solve almost all the numerical problems, and I will expect you guys to do the problems of your NCERT backside too, right? It's not that tough, guys, if you work hard. Right, now straight away we are going to the parallax method. After finishing off the topic which I have arranged for today, I will give a quick review for the entire section, okay, so that it will be very understandable for you guys. Okay, and the next major topic which we are going to take is parallax method. What it is? Parallax method. Right, what do you mean by parallax? This is something which you have seen in your entire life, guys. It's not a big deal. See, I am having a pen like this, right? I'm looking at the tip. It's better I talk about the tip of the pen, right? If I want to see the actual position of the tip of the pen, I have to look straight, right? From this point, from above, I have to look. Right, that is the way of looking at any point or any object, right? You have to straight or look at it straight. But what happens if I am seeing from this side, from the left side and from the right side? I'm looking at two perspectives, right? From left and right, right? When I look from left side, I might see that this nib is moving towards the right, or it is aligned towards the right direction. If I look it from the right perspective, the nib might be looking at the left direction, right? The alignment will be different. That is, you will see that there is like, if from right, if you are looking, it's like this, and from it will seem. Is it actually so? No. It seems that the nib is in this direction. Or if you want a better understanding, let's say there is a pointer, you are marking this. Okay, you are looking at the weighing gauge on which you are standing. Right, and there will be a lot of readings like this. How are you supposed to see the value? You have to look straight, right? You have to look. Your teacher or the doctor would also ask you guys to stand straight. Don't bend, right? Don't bend while you are weighing your weight, right? Similarly, and they would also prefer, they will stand over here and look at the weight, from here they look. They don't look here, or they don't stand over here and look how much is your weight. They stand at this position, look at it straight, and then say how much is your weight. Why? Because suppose the person is standing over here and he is looking at this value, means he would say this point. Suppose this is your, let's say, 50 kilograms, right? This is 51 and this is 49. A person who is standing here and he is looking at this pointer, for him this pointer might be at this position, so he will read the weight of the person as 51 kilogram, right? Similarly, if there is another person, he is standing over here, for in his perspective this pointer would be seeming from this position, so for him it might be what? 49 kilograms, right? I'm just telling that the reading 50 kilogram will not be seen by either person at these 2 points. Clear? This error of reading due to the positioning is known as parallax error. What it is? Parallax error, which we will deal later on also, but I want you guys to understand what is parallax. And this is an error of measurement, right? This process can be used for measuring a very long distances. That is, I can say extraterrestrial objects like planets, satellites, etc. And that method of measuring then extreme long distances using the error process called parallax error is known as parallax method. So I hope you understood what parallax method is, right? So I can say the first section which now I'm going to deal with is long distance calculations, right? How I'm going to calculate long distances or long length, right? So first method and the only method which you are learning in 11th class is parallax method, right? So we are going to deal with some extraterrestrial distances. So after that we'll deal with some terms also. So before that, so we'll take the best example of finding the distance of a planet from Earth. We are going to find what? We are going to find the distance of a planet from Earth using parallax method, right? So obviously I have to consider a planet. Say this is our planet. It will be very small, right? And say this is my Earth or our Earth. So I'm going to observe this point P or planet P from two observatories, right? Let's say this observatory is A and this observatory is B. And using telescope, I'm going to look at planet P, right? This much clear? Now I drew Earth in curvature form because Earth is actually in this shape from an extra point of view or outside point of view. But actually if you are standing over here and another person is standing over here, you will see the length or the distance between them is actually a straight line, right? Why? See, we'll also realize this section. Suppose this planet, from the Earth is very, very large, right? Say let the distance be d between the planet and the observatory, and say I'm going to consider another observatory such that it is also at a distance d. I don't know that value, but equidistant. We are going to find this distance of planet from the observatories, right? Now what happens is, see, if this point or this planet, if I'm considering here close, right, at that time this arc is very significantly seen as a arc itself I can see. But as this point moves away, this arc's bend goes on reducing and it assumes a straight line. Now that means if P is so high or it is very, very large point distance such that this arc AB can be assumed as a straight line, right? Now this straight line indicates the actual distance between AB. Let's say that distance is B. That is the distance between two observatories. And say L is the arc length actually. So AB, arc length is L, distance between AB is B. I hope you understood what is the difference. That means if D, that is the distance between the planet and the observatory, is very, very large, right? When compared, right? The distance is very large when compared to the distance between the actual distance between the observatory. That is capital D is very, very large when compared to small b. In this condition, this L or this arc is assuming the straight line face. So I can say L is equivalent to B, not equal, equivalent. Clear? Now, what do you mean? This is the angle subtended. Let's say theta is the angle subtended by the two observatories, telescope or by the two observatory at the planet theta, right? This much clear? Now I can assume this as a simple section. I hope you remember the equation for angle subtended. Theta is equal to arc length. What is arc length here? AB, arc length by radius. This, if it had been a part of circle, this becomes the radius. So this is D. Now AB arc length, which is L, is equal to B or equivalent to B. So I can write here B divided by D is equal to theta, or I can say what? D is equal to B by theta. Right? So what is the B? That is the distance between the two observatories, which you can easily calculate. Now Then what is theta? That is its angle subtended. How can I measure this angle? This and all have not been mentioned in your textbook. I am just telling you. See, I am using a telescope to view this planet. And when I move the telescope, can't I find how much angle it is rotating? Yes. Say this angle rotation is x. Similarly, a telescope is used from this observatory to view P, and that angle say is y. Then what will be this sum of x, y and theta? It is a triangle, right? So it will be 180 degree. So x can be measured, y can be measured, 180 degree is a known value, so you can find the value of theta. So B's value is given, or you can measure easily. Theta can also be measured. So you can find the distance of a planet from the Earth's surface using this formula. Clear? So I used parallax method. Why? I am looking at the same thing from two perspectives. Clear? I am not looking at it straight. I am looking at it from two other points. So that's why it is known as the parallax method of finding the distance. Clear? Now using parallax method, the second thing I am going to find is diameter. What it is? Diameter of the planet. Okay, I am going to find the diameter of the planet. Now how would I find it? So say this is our planet. See? Diameter D, and this is our Earth surface. Say this is our surface observatory, and I am going to look at the two edges of the planet from an observatory. Say this is A, right? I want to measure the diameter of this planet. Now the same planet, okay, the previous P planet is this one, right? So by the easier or the earlier process, I have already found capital D, that the distance of the planet from the observatory, right? So let's say there, this is the angle phi. Theta I have used earlier, so I will write it as phi. Phi is the angle subtended by the planet on the observatory, right? Now this can be easily measured. How? I will be using a single telescope. First I use the telescope to look at this edge, right? Similarly, the same telescope was inclined towards in this direction to see this edge. So the angle between the two positions of the same telescope can be easily found, and can find the value of phi. Now again I am using the same formula, guys. Remember, phi, angle subtended, is equal to arc length. What is the arc here? D, right? Divided by the radius, that is capital D. Or I can say, you are asked to find D, right? Small d, that is equal to phi into D. Phi I can measure. I told you before how it is done. Capital D is found by the earlier process. So I can find the value of what? Diameter of the same planet using parallax method. I hope this is clear, right? Now there is a small thing which is it has to be taught you along with something which has to be mentioned now, that is 6.3. Example 6.3 and 6.4 gives you two numerical problems in your NCERT book. I request you guys to go through it, and I think it is very easy if you understood this portion. Clear? The calculation part is only something which is different, and the calculation part in these two questions is something which you have to be taught, that I am going to tell now. Okay. Now, that is, you are going to be introduced two terms here, guys. That is minutes and seconds. In case of angles, not in the case of our clock. Minutes and seconds in the case of what? Degrees, or I will say angle. So we'll start with it. So I hope you remember what was 360 degree in radians. 360 degree, I'm going to write it in radians as how much? 2 pi radians. I hope you remember this part. So what is 1 degree, guys? It is 2 pi divided by 360 radian, or I can write it as what? Pi by 180. If I put the value of pi as 22 by 7, and that I am going to divide by 180, I will get a constant value which goes off or non-terminating value, but we'll take it as 1 degree in terms of radian is 1.745 into 10 to power minus 2 radian. This is the value of 1 degree in radians in decimal value. Clear? Not in forms of pi. In decimal value. This has been given in your NCERT in the problem of 6.3, 6.4. But I would request you guys to understand it. Clear? Right? Now, I told you, so I got 1 degree in terms of radians, that is the decimal value system. Now I told you I'm going to introduce what minutes, right? So you would have seen in compass, that is your mobile's compass, or you would have seen in your maps, etc., that latitude, altitude, etc. are written in this form. Have you seen? That is 30 degree, 40 minutes, 1 dash, 65 double dash seconds. So 1 dash, this is called minute, double dash, it is seconds. I hope you have seen this one. If not, please look into it. Right. Now 1 dash which is written is known as minutes. Clear? Now that conversion I'm going to tell you. See, 1 degree is 60 minutes. How much? 1 degree is 60 minutes. Sorry, 1 dash only. Right. So what will be 1? So here in 1 degree I have written as 1.745 into 10 to power minus 2 radian, right, is equal to 60 minutes, right? So can't I write 1 minute is equal to 1.74 into 10 to power minus 2 divided by 60 radian, right? Now after calculation you will get the value of this value as 2.908 into 10 to power minus 4 radian. This is calculated thing. Please calculate it, guys, later on, right? And this value also has been given in your NCERT textbook. Now I don't want to leave this page, guys, because the next page I'll be taking for the next topic. So bear with me. Now I'm going to write here in the case of seconds. Clear? Now minutes is over. Now similarly 60 seconds, right, double dash is equal to 1 minute. 60 seconds is equal to 1 minute, right? Now what is 1 minute? Now in radians form we just wrote it as 2.908 into 10 to power minus 4 radian, right? So here from here, so 1 second is equal to 2.908 into 10 to power minus 4 whole divided by 60 radians. I get the value, or you will get the value as 4.8467 into 10 to power minus 6 radian. This is the answer you will get. Bear with me, guys. I'm extremely sorry I'm using this crowded side, but I wanted to write this entire topic in the same page itself, so that the next page will be a fresh topic. Clear? I hope this much is clear, guys. Right? Now that means I'm just going to review it, because in the new topic I don't think I can complete in 2 minutes. So let's move on. So I'm going to revise the topics. First we started with how to find this problem. I'm not going to take it again, guys, please review it. Now we are going to find the second problem, that is you are asked what is the angle subtended by a solid sphere at its center. We consider an external sphere of bigger radius r, and if you are assuming a source light kept over here, due to this inner sphere a shadow is exhibited on the outer sphere, right? Now that shadow is having an area of 4 pi r square, so this shadow can be taken for the angle subtended formula, so that A is equal to 4 pi r square, that is outer sphere, divided by r square. This is the formula of what? Solid angle, and the unit is in steradian. So single sphere, angle subtended is 4 pi. Similarly, if it becomes hemisphere, it becomes half of it, so it will be what? 2 pi steradian. Now the same is the case of a cube which is present over here. All the faces totally, if you are placing it in a sphere, just like the previous case, the shadow will be exhibited on the entire sphere. So the angle subtended will be 4 pi steradian itself. Now we are asked if what will be the angle subtended by single face, means 6 sides or 6 faces is giving this much angle, means one face will be giving 4 pi divided by 6 steradian, that is 2 pi by 3 steradian, right? The next topic which we dealt with is parallax method. That is, what is parallax error? Looking at a point or measurement from two point of views which causes an error in reading is known as parallax error. And that method is using that parallax error to find long distances is known as parallax method. And we are first dealing with the distance of a planet from Earth's measurement. We consider two stations on Earth's surface. It is at a distance d from the planet, and the theta is the angle subtended at the planet by the two stations. Now L is the arc length between the two stations, and B is the actual distance between them. Now since capital D, that is the distance between the planet and the Earth, is so large when compared to the distance between the stations, we are going to assume that B and L is equivalent, so that theta is equal to arc length L. In place of L, I am writing B divided by capital D. Capital D is equal to B by theta. Right? Now next section which we are going to deal is diameter of the planet. We have already found the value of distance of the planet from the Earth's surface. So we are considering an observatory A, and we are from observatory A, we are looking at the two extreme diameter points of the planet. Right? Now this angle phi can be calculated by measuring the angle in line between the telescope's position. Now by calculating phi and known value d, you can find the d, that is diameter of the planet. This much clear? Right.